Good afternoon, teacher. Today we present a project of the biomedical engineering area, which is called Start, Stop, and Inversion of a Spin for DC motor. My team is made up of Hernández Díaz Carlos Rafael, Nuricumbo Viaña Diego, Santiago Rodríguez Cristian Daniel, Solís Agustín Fabiola, y Pinlandis José Luis. Introduction. The project to be ourselves is based on the implementation of a logic circuit which is made of various logic gates such as AND gate, NOT gate, and OR gate, which through an arrangement and distribution of these will make a high level reach a power circuit made of transistors in arrangement called H-bridge. The purpose of the project is to be able to control the rotation of a moderate quality with the use of logic gate and transistor through switch. Among the applications that can be given to this project, we find as an aid to raise or lower the power windows in household appliances such as blenders or mixer in larger applications such in the mechanical industry, machines called lathe. In many others where the same operating principle is applied.
Hi, my name is Diego Comudenya. Let me introduce to you the methods and the materials in order to complete this project successfully. This here is the list of materials that we're going to use, and I will explain how these devices works. Alright, we have here the push button. These are switches that allows or not the circulation of the current, the electric current. These switches are manual because they act directly. You can touch it and it's going to work. And now here we have the AND logic gate. This indicates that it's necessary for all its inputs to have binary state 1 in order to get the output binary state 1. Now here we have the OR logic gate. I forgot to say that AND logic gate in Boolean algebra works as a multiplication. The OR logic gate works as a sum, and this gate allows that any of its inputs that have binary state 1, its output will go to binary state 1 as well. Now here we have the NOT logic gate. For this situation, 1 will be placed at the input and a 0 will be given at the output. Otherwise, it will receive a 0 and display it. Basically, if I got 1, it will this logic gate will give me 0, and if I have 0 at the output, I'm going to get at the input. If I get 0 in the output, I'm going to get 1. Alright, the resistance. It is a measure of the position of the current flow in an electrical circuit. Now here we have the transistors, that it's mainly used for the general purpose amplification and medium power switching of applications. Now we're going to use a 5 volts motor. It is a machine that converts electrical energy into mechanical energy, causing a rotatory movement. This is a motor. Now we have the protoboard, that basically it's board made of holes that are electrically connected to each other internally. And now we're going to use the 9 volts battery that basically is going to provide all the energy to all the circuit. Thank you.
My name is Fabiola Solis, and I will talk about the procedure and methodology of this project. The circuit of a project consists of a diagram that presents the starting, stopping, and reversal of rotation in the movement of a motor. The purpose of our project is to be able to control the rotation of a motor electronically with the use of logic gates by means of switches. Um, our project consists of two main circuits, one for starting and one for stopping, uh, which are interconnected by an AND gate and two inverters. Uh, our inverters are the 74LA04, which were as protective locks to about the margin the motor. Uh, well, uh, our pros first we will start by placing the components in a specific place. The first NC push button should be connected on the upper left side of the breadboard, which will be the general one for the circuit. Then the next two NO push buttons will be placed in such a way where each pair of pins will be on opposite sides of the breadboard. And having located the respective places of these elements, we will proceed to connect the main power of all electronic components properly as shown in the pin diagrams above. Here, uh, making the corresponding connection of the pins connected to the positive side and the corresponding pins to ground. In this way, all components will be energized for operation. Uh, Now, the push button connection will be made to the main logic gates, and in this case, N and R, and relationships connections between the multiplier and other gates as shown in the diagram. Which will be feedback to each other. Mhm. Um, Then the other relationship connections between the following other and inverter gates will be made. This node and OT gates will have the task of reversing the rotation of the engine. Uh, well, and this part is our simulation. For the simulation of the project, we use the Proteus application. We start by selecting the components in the simulator. Uh, for to start the simulation and check the current functioning of the project, we have to press P2, and when P1 is closed, the movement of the motor is made in anti-clockwise direction. And if we open P1 without activating P2, the motor will tend to stop. And the same way, the same thing is done with P3. When P3 and P1 are closed, the motor will turn clockwise, giving this way the control of the motor. Thank you.
Hi, my name is Cristian Santiago, and then I will talk about the principle of operation of this project. Operation of the H-bridge with transistor BJT. An H-bridge is an electronic circuit that is generally used to allow a DC electric motor to rotate in both forward and reverse directions. In this case, for this project we use it as a power converter which was built with BJT-type transistors using them as switch. This is the second phase of the circuit. The basic principle of operation of the H-bridge deduces that when switch AS1 and AS4 are closed, the transistor AS2 and AS3 will be open. Then the motor will be crossed with the voltage in one direction, to which the motor will rotate. However, if we open AS1 and AS4 and close AS2 and AS3, say voltage will have inverted and the operation will reverse the direction of motor rotation. As soon as the corresponding push buttons are activated, the logic gates perform a series of steps to generate an output at a high level towards transistor AS1 and AS4, so that is when detecting the high level are activated and allow a current to pass that will cause the motor to rotate towards the right side. Therefore, the startup phase is started. In the following operation to reverse the rotation of the motor, another pair of push buttons with another combination will be activated. In a special case where the brown buttons are activated at the same time, the transistor S1 and S3 will close, or in another case the transistor S2 and S4. There will be two currents that collide and cause a short circuit, and as a consequence the motor is broken. As a result, the motor works like a cycle sensor to start in one direction. It is necessary to activate the fixed normally closed push button combined with one of the two normally open push buttons, and in case we want to reverse the rotation, we must press the first push button again along with another combination to do this operation. That is all from me. Thanks.
Hi, my name is Carlos Rafael Hernandez Diaz, and I am going to explain to you how we obtained the truth table of the project. Okay, the operation of the entire circuit with its components integrate into the following truth table. As we can see in the previous truth table, we have three inputs, A, B, and C, that correspond to start, to stop, and change of rotation of the motor respectively, generated by the push buttons. We start with 3 and state none. The buttons are inactivated. Then the circuit is in state initial and the output of the logic gate is 0 and does not arrive voltage or current to the transistors. When the toggle button is a high level, the other buttons are at a low level. That is, they are not activated, and a high level is generated at the output as the cause the motor begins to rotate to opposite side to which it is accustomed, that is to left side. When a stop button is a high level and the other two buttons are in a low state, the output is 0. The circuit remains open as push buttons are normally closed, and when this pressed, it opens the circuit. In the event that two stops and chain buttons are activated, the output will be a low level because pressing the stop button opens the circuit and logic components cannot generate a high status. If only the start button is pressed because it's evident, the output will be a high state and the motor will begin rotate in normal direction, that is towards the right side. If in one case the start button is pressed and the shift button, the output will be a high level. When pressing the change stop button, when pressing the start and stop buttons, the output is a low, as the circuit remains open. Finally, if their buttons are at high level, that is are held down, the output of logic circuit will be zero, since only by pressing the stop button of the circuit stay open. Okay. Okay, simplification by Carnot. As complementary way, we decide to simplify the truth table with the Carnot method, leaving the following equation in the magic. With this, we could say that equivalent reduced circuit is made up of a not negative gate, two AND gates, and or other gate. This will show that in the same way reduced circuit present gates used in the original circuit implement for this project.